Applying the laws of logarithms. The laws may be used to rewrite logarithmic expressions in a form more useful for the application at hand. They may also be used to facilitate the solving of logarithmic equations. Example: write the common log of x squared plus 2x plus 1 minus the common log of x plus 1 as a single logarithm. Applying law number 6, we get the difference of the logarithms is equal to the log of the quotient x squared plus 2x plus 1 all over the binomial x plus 1. Factoring, we get the log of x plus 1 times x plus 1 in the numerator over x plus 1. We can reduce the fraction inside the logarithm, and we get the common log of x plus 1. Example: write the log base 2 of x minus 2 plus 3 times the log base 2 of x plus 1/2 times the log base 2 of 9 as a single logarithm. We begin by applying law number 7, rewriting coefficients as exponents on the arguments of the logarithms. We have log base 2 of x minus 2 plus log base 2 of x to the third power plus log base 2 of 9 to the 1/2 power. Next, we simplify the radical, that is, rewriting 9 to the 1/2 power, or the square root of 9, as 3. Now we apply law number 5, which says the sum of the logarithmic expressions is equal to the log of the product. We have log base 2 of 3x to the third times the binomial x minus 2. Then we distribute, and we have the log base 2 of 3x to the fourth minus 6x to the third. Example: write the natural log of 4x to the fourth divided by the binomial 2x minus 5 as a sum or difference of logarithms. Rewrite any exponents as coefficients by law number 5. We begin by applying law number 6, rewriting the log of the quotient as the difference of logarithmic expressions. We get the natural log of 4x to the fourth minus the natural log of 2x minus 5. We then apply law number 5 to the product 4 times x to the fourth, and we get the natural log of 4 plus the natural log of x to the fourth minus the natural log of 2x minus 5. Finally, we apply law number 7, rewriting the exponent on x to the fourth as a coefficient of the logarithm. The final answer is the natural log of 4 plus 4 times the natural log of x minus the natural log of 2x minus 5. Example: solve the log of 3x minus 1 plus the log of x equals 1. We begin by applying law number 5, rewriting the sum as a product inside the log, and we have the common log of x times 3x minus 1 is equal to 1. Multiplying, the log of 3x squared minus x is equal to 1. Rewriting in exponential form, 3x squared minus x is equal to 10. The base of the common log is 10. Now we solve the quadratic equation by factoring, and we get 3x plus 5 times x minus 2 is equal to 0. Applying the 0 property, we get two linear equations: 3x plus 5 is 0, or x minus 2 is 0. Solving each of these, we get our two potential solutions. X is negative 5/3 or x is 2. We must consider domain. Looking at the original equation and the two expressions, we see that the log of 3x minus 1 restricts the domain to positive reals greater than 1/3. Negative 5/3 is not part of the domain. It cannot be a solution to the original equation. So our only solution is x equal to 2. Example, solve 2 times the log base 5 of 3x equals the log base 5 of 9. We begin by applying law number 7 to rewrite the coefficient as an exponent. And we have log base 5 of 3x squared equals the log base 5 of 9. Simplifying or squaring, we have the log base 5 of 9x squared equals the log base 5 of 9. Applying law number 9, the equation becomes 9x squared equals 9. Dividing by 9, x squared is 1. And applying the inverse, taking square roots of this equation, we get x equals plus or minus 1. Two potential solutions, x is minus 1 or x is positive 1. Again, we must consider domain. In this case, looking at the original equation and the log expressions within it, the domain is the set of positive reals, which means x equal to minus 1 cannot be a solution to our original equation. So we get one solution, x equal to 1. Example, solve the log base b of x minus the log base b of x minus 1 equal to 1. Applying law number 6, we rewrite the difference of logarithmic expressions as the log of the quotient, log base b of x all over x minus 1 equal to 1. Inverting into exponential form, we get the quotient x over x minus 1 is equal to b to the first power. Multiplying both sides of the equation by the factor x minus 1, we get x equals b times the binomial x minus 1. Distributing, x is equal to b times x minus b. Solving for x, subtracting the term b times x from both sides of the equation, we have x minus xb equals b. Factoring, we get x times the binomial 1 minus b is equal to b. Finally, solving for x, dividing both sides of the equation by 1 minus b, we get our solution x is equal to b over the binomial 1 minus b. As always, we must consider domain. The domain of this logarithmic equation are positive reals greater than 1. So the question is b over 1 minus b in the domain for all values of base b? Why?